Hello, my name is Stan Kikot, and I'm going to present our joint work with Michael Benedict, Peter Astropolsky-Nalivaya, and Miguel Romero. This talk is on view-based query answering. Suppose we are given a database I with a system of views V. So we have the original database I, its view image Vi, and a query Q in terms of the original database. The main problem of view-based query answering is, given query Q and view definitions V, decide whether we can answer Q if we only have access to the materialized views, but not to the original database. And if it is, to construct a rewriting of Q in terms of view tables. A natural application of this problem is cached-based query answering. Suppose that we have a client which sends queries to a database server and stores its replies in a local cache. Now it receives a new query and wants to decide if it can be answered using only local information without accessing the server. This is exactly view-based query answering, where the views are the cached queries. Another application is analysis of privacy and security in information systems. Suppose that the original database is private, while the view describes its public image, and we have an adversary who wants to learn some sensitive information, which is specified by Q. So view-based query answering can be used for modeling attacks against privacy with an adversary capable of unlimited logical reasoning. We need to clarify what we mean by answering a query using views. And there are a few ways to formalize this. A very general notion is query determinacy. We say that a query Q is determined by V if its output is the same on all database instances with same view images. In other words, if it is a function of the view image rather than of the original database. If in addition this function is monotone, we say that Q is monotonically determined by V. Monotone determinacy is known to be decidable if views and queries are conjunctive queries, and also when views and queries are regular path queries. Plain determinacy is known to be undecidable in both cases. So we focus here on monotone determinacy and its strengthening. For example, we can fix a query language L and talk about L rewritability of a query over views. Q is L rewritable over views V if there is a query phi in L in view signature, which for each instance when executed on the view image gives the same answers as the original query executed on the original instance. If L contains only monotone queries, this is a strengthening of monotone determinacy. To illustrate, consider a schema that contains a binary relation R and a unary relation U. Suppose that we are interested in those X's from which U is reachable via the binary relation R. We have unary views V0 and V1, which consist of the points from which U is reachable in even and odd numbers of steps respectively. Then Q is monotonically determined by V0 and V1, but not by V1 alone. This slide also contains an example of what we call a data log program, which consists of possibly recursive definitions of intentional predicates. Here we have a unary predicate P, which we first initialize by U and then update following this rule. This particular program is monadic, since the recursive predicate is unary. General data log may have intentional predicates of arbitrary. This is the methodology of our research. We pick possibly different monotone recursive query languages or queries and views, such as data log as its fragments, frontier-guarded data log and monadic data log, and also non-recursive standard languages like conjunctive queries or unions of conjunctive queries. For each pair of languages, we try to understand, is monotonic determinacy decidable for this pair of languages? And if it is, what is its complexity? And if it is equivalent to rewritability and data log. To each question, we obtain both positive and negative results, which we fit in two-dimensional tables. Here, I'd like to highlight two of our results. First, for queries in monadic data log and views where some of the views are in frontier-guarded data log and some of the views are conjunctive queries. Monotonic determinacy is decidable in triple exponential time and is equivalent to the rewritability in data log overviews. This result is obtained by establishing bounds on 3 bits of the structure considered and representing them using 3 codes and 3 automata. Second, for monadic data log queries and UCQ views, monotonic determinacy is undecidable and is not equivalent to rewritability in data log overviews. Here, we use undecidable tiling problems, pebble games, and an example of a constraint satisfaction problem undefinable in data log by Atserias, Bulatov, and Dalmau. Now I'm going to sketch the proof for the first of these two results. We build on coding of relational structures of bounded 3 bits by labeled trees and classes of such structures by 3 automata. Here we have 2 parameters, W, the size of the bags, and persistence P, showing in how many bags an individual can belong. Our first observation is, given a data log query Q, it is easier to construct a 3 automata A unfold, which represents the set of unfoldings or secure approximations of Q. The states of the automaton are in one-to-one correspondence with the rules of the data log program. For example, for this reachability query, its secure approximations are secures which express reachability in 0, 1, 2, 3, and so on steps. They all have a natural decompositions like this, with 2 types of bags, for R and for U, and the automaton roughly recognizes the words of the form R star U. Now we need to take the views into account and construct an automaton which recognizes the view images of secure approximations of Q. This is easy to do for frontier-guarded views because they create view predicates only inside the existing bags, and so we can keep the old structure of the tree code. However, it is not as easy as this with CQ views. For example, consider the reachability query from the previous slide and let V be the binary two-hop view. Then the application of this view can create view atoms that do not fit entirely in existing bags. We deal with this problem by extending the bags, and this technique works provided that V is a connected CQ and that we can have a bound on the persistence of the original tree code, which is the case for monadic, but not for frontier-guarded original query. At the end, we obtain an automaton A view image, which recognizes the set of view images of secure approximations of the original query. Here is a diagram of a standard procedure for checking monotone determinacy of Q over V. We start with some unfolding or the secure approximation Qi of Q, take its view image, and then apply so-called inverse rules. In other words, replace each view atom by some of its definitions and obtain a structure J, which we call a test instance for Q and V, which, in case of monotonic determinacy, must satisfy Q. So, Q is determined by V if and only if Q holds on all test instances J. We can mimic this entire pipeline with automata. For queuing monadic data log and a mix of secure and frontier-guarded data log views, we argue that all test instances are of bounded array bits. Then we use a view image to construct an automaton for all test instances and check inclusion between this automaton and the automaton for queue. Moreover, in case of monotonic determinacy, we can transform a view image into a data log rewriting of view in terms of B. I can tell you more about this if you ask me to during the question session. To conclude, we obtain new positive results on the decidability of monotonic determinacy and on its equivalence to data log rewritability. We also obtain negative results when these two properties fail already for the monadic data log queue and UCQ views. Negative results are based on absolutely different techniques, which you can find in our paper. Here are directions for future research that stem out from this paper. First, as we discovered that there are monotonically determined data log queries and views without data log rewritings in terms of views, a big open question is to find sufficiently expressive languages for view-based rewritings. Second, our results on the rewritability of monotonically determined queries into data log are obtained through 3 automata and so involve a doubly exponential blow-up in the size of the program. It is interesting to see if it is possible to design a more succinct view-based rewriting procedure, for example, based on crack interpolation. There are also some open questions that I'll leave without a comment. This is it. Thank you for your attention.